The periodic table is a table of the chemical elements in which the elements are arranged in order of atomic number, in such a way that the periodic properties of the elements are made clear. We can understand the properties of an element by noting the position of that element in the periodic table. For example, consider an element X having atomic number 12. The electronic configuration will be 2, 8, 2. From this we can understand that the group is 2 and the period is 3. If the element Y is just above the element X, then its electronic configuration is 2, 2. From this, it's clear that the valency for both elements X and Y are same. Bohr model of atom. According to this, the electron move around the nucleus in definite paths. These definite paths are called as orbits or shells. In Bohr model, each atom has shells K, L, M, N. These can also be referred to as 1, 2, 3, 4 energy levels respectively. In K shell, there are 2 electrons. In L shell, there are 8 electrons. M shell, there are 18 electrons. N shell, there are 32 electrons. The electrons present in each shell or orbit will have a definite energy. That is why the shells are also called as energy levels. As the shells move apart from the nucleus, its energy level increases. Electrons are accommodated in shells in increasing order of energy. Subshells. Electrons in each energy level are distributed in various sub-energy levels called subshells. They are named as S, P, D, F, and so on. The maximum number of electrons in S subshell is 2. The maximum number of electrons in P subshell is 6. The maximum number of electrons in D subshell is 10. The maximum number of electrons in F subshell is 14. The energy levels of the subshells are as per the order given below. S is less than P, is less than D, is less than F. Let us see how to write the electronic configuration of some atoms. First, hydrogen. Its atomic number is 1. Therefore, the electrons get filled in the S subshell of first orbit. The electronic configuration is 1s1. Helium, atomic number 2. Electronic configuration 1s2. Lithium, atomic number 3. Electronic configuration 1s2, 2s1. Carbon, atomic number 6. Electronic configuration 1s2, 2s2, 2p2. Sodium, atomic number 11. Electronic configuration 1s2, 2s2, 2p6, 3s1. Chlorine, atomic number 17. Electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5. Argon, atomic number 18. Electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6. As energy levels increase, we can record the number of electrons filling up in the following order: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f. Let us try to write the electronic configuration of some other elements. Scandium, atomic number 21. Electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Similarly, the electronic configuration of chromium, whose atomic number is 24, should be written as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. But 3d5 is more stable than 3d4. One electron from 4s will go to 3d, and the real electronic configuration becomes 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. Similarly, the copper having atomic number 29 will have the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. The blocks in periodic table. Based on the electronic configuration, the elements are classified into 4 blocks: S block elements, P block elements, D block elements, and F block elements. The elements of 1 and 2 groups are called as S block elements. The elements from group 13 to 18 are termed as P block elements. The elements from 3 to 12 groups are called as D block elements. The F block elements are arranged as 2 levels just below the periodic table. The S and P block elements are collectively known as representative elements. D block include transition elements. All transition elements are metals. Example: copper, iron, zinc, etc. The characteristic features of transition elements. Transition elements show variable oxidation states. For example, when iron reacts with chlorine, 2 types of compounds are formed. Ferrous chloride FeCl2. Here the oxidation state of iron is +2. Ferric chloride FeCl3. Here the oxidation state of iron is +3. Transition elements form colored compounds. Example: ferrous sulfate is green colored, while ferric sulfate is brown colored. Transition elements form complex compounds. Let us see more examples of the colored transition complex compounds. Copper sulfate, blue. Cupric chloride, green. Cobalt nitrate, pink. Manganese dioxide, black. The F block elements include lanthanons and actinons. Lanthanons of F block elements are commonly known as rare earths. They are commonly found in beach sands of Kerala. Uranium and thorium are important among actinons. Most of the actinons are man-made and radioactive elements. Electronegativity. Electronegativity is the capacity of each atom involved in bonding to attract bonded electrons towards it. The most electronegative element is fluorine. Its electronegativity is 4. Pauling scale. Pauling scale is used to compare the electronegativity of various elements. It was developed by an American scientist, Linus Pauling. In this scale, electronegativity value of elements varies from 0 to 4. When two atoms combine, the nature of the bond between them is determined by the difference between their electronegativities. If the difference in electronegativity is more than 1.7, then the bond is ionic bond. Example, when sodium electronegativity equals 0.9 and fluorine electronegativity equals 4.0 reacts together, they form ionic bond because the difference in electronegativity is 4.0 minus 0.9 equals 3.1. If the difference in electronegativity is less than 1.7, then the bond forms will be covalent bond. Example, when hydrogen electronegativity equals 2.1 and chlorine electronegativity equals 3 reacts to form hydrogen chloride, covalent bond is formed because the electronegativity difference is 3.0 minus 2.1 equals 0.9. Polar covalent bonds. If the electronegativity values of the two atoms involved in covalent bonding are different, the bonded electrons show a tendency to move closer towards the atom of high electronegativity. As a result, the atom of higher electronegativity gets a partial negative charge, and the other with lower electronegativity gets a partial positive charge. These types of bonds are said to be polar covalent bonds. The partial charge on atom can be represented as delta positive and delta negative. Example, in hydrogen chloride, hydrogen will have delta positive and chlorine atom will have delta negative charge. The polar molecules will have partial ionic character. Water, hydrogen fluoride, ammonia, etc. or other compounds have polar nature. Ionization energy. The minimum energy required to remove the most loosely bounded electrons from an isolated gaseous atom is called ionization energy. It is expressed in kilojoules per mole. As the size of atom increases, the ionization energy decreases. As we move from left to right along a period, the ionization energy increases due to the decrease in the size of atoms. As we move down in a group, the ionization energy decreases due to the increase in the size of atoms down the group. Dmitry Mendeleev is the creator of the modern periodic table. Chemistry has undergone a lot of revolutionary changes due to the modern periodic table.